8342. What device is used to convert alternating current which has been induced into the loops of the rotating armature of a DC generator to direct current? A. A rectifier. B. A commutator. C. An inverter. The correct answer is B. The commutator is a device that consists of a set of segmented copper bars or segments attached to the armature shaft. These bars are electrically insulated from each other. As the armature rotates, the segments of the commutator come in contact with stationary carbon brushes, which are connected to the external circuit. The commutator serves the purpose of reversing the direction of the current in each coil of the armature as it rotates. This reversal ensures that the output current from the generator remains unidirectional or direct current. By periodically switching the connections between the armature coils and the external circuit, the commutator ensures that the generated current flows in one direction, producing direct current. 8343. A certain direct current series motor mounted within an aircraft draws more amperes during start than when it is running under its rated load. The most logical conclusion that may be drawn is A. The starting winding is shorted. B. The brushes are floating at operating RPM because of weak brush springs. C. The condition is normal for this type of motor. The correct answer is C. When a DC series motor starts, it experiences a higher current draw compared to when it is running under its rated load. This is because during startup, the motor requires a higher torque to overcome the initial inertia and get the load moving. The higher current drawn during startup is a result of the increased torque demand. As the motor reaches its operating speed and the load is applied, the torque requirement decreases, resulting in a reduction in the current drawn by the motor. Once the motor is running under its rated load, the current drawn stabilizes at a lower value. 8344. The stationary field strength in a direct current generator is varied. A. By the reverse current relay. B. Because of generator speed. C. According to the load requirements. The correct answer is C. When the load on the generator increases, such as when more electrical devices are connected and drawing power, the field strength needs to be increased to maintain a stable output voltage. This is done by increasing the current flowing through the field winding, which strengthens the magnetic field. Conversely, when the load on the generator decreases, the field strength can be reduced to prevent the voltage from becoming too high. This is achieved by decreasing the current in the field winding, which weakens the magnetic field. 8345. What type of electric motor is generally used with a direct cranking engine starter? A. Direct current shunt wound motor. B. Direct current series wound motor. C. Synchronous motor. The correct answer is B. A direct current DC series wound motor is well suited for this application. In a series wound motor, both the armature winding and the field winding are connected in series. This configuration allows the motor to deliver high starting torque since the current flowing through both windings is the same. The high starting torque is achieved because the armature current also flows through the field winding, generating a strong magnetic field. This strong magnetic field interacts with the field produced by the stationary poles, resulting in a high torque output. 8346. Upon what does the output frequency of an AC generator alternator depend? A. The speed of rotation and the strength of the field. B. The speed of rotation, the strength of the field, and the number of field poles. C. The speed of rotation and the number of field poles. The correct answer is C. The output frequency of an AC generator, also known as an alternator, depends primarily on two factors: speed of rotation. The output frequency is directly proportional to the speed at which the alternator rotates. Increasing the rotational speed increases the frequency, and decreasing the speed decreases the frequency. This relationship is known as the frequency-speed relationship. Number of field poles. The number of field poles refers to the number of magnetized poles on the rotor of the alternator. The output frequency is directly proportional to the number of field poles. As the number of poles increases, the frequency increases, and as the number of poles decreases, the frequency decreases. This relationship is known as the frequency-pole relationship. The strength of the field mentioned in option A does not directly determine the output frequency, but affects the overall performance and voltage regulation of the alternator. Therefore, the output frequency of an AC generator or alternator depends on the speed of rotation and the number of field poles. Option C, the speed of rotation and the number of field poles, is the correct answer.